Very good morning, dear students. My name is Naveen Verma. I have teaching experience of 12 years of coaching JEE aspirants. Today, before you, I would like to mention a topic. This is the vertical circular motion. Now, let's discuss. Suppose this is a circle in a vertical plane, and this would be the string. This is the string. One end of this string is attached, or you can say hinged, at the center of this circular path O. To the other end of this string, a stone or particle is attached whose mass is equal to small m. This is the particle whose mass is equal to small m, and we call this point as A. So this is the point A for us. Now this particle will circle in this vertical circle. First of all, we shall have to analyze what would happen with the tension in the string as a particle moves from bottom to top. In order to understand the variation, suppose at any juncture or at an instant of time, our particle, our particles pose here. So this is the position of the particle at this juncture, and the orientation of the string with its initial position, or you can say with vertical, is this one. Suppose this is small angle is how much? This is small angle is equal to theta. So this is small angle is equal to how much? This small angle is equal to theta. In order to understand the variation, first of all we shall have to make the FBD of this particular stone. Can you tell me how many forces will act? Yeah, sure. This is the weight mg which will act downward, or you can say which will act towards the center of earth. This would be the centrifugal force which will act away from the center. Keep in mind that I have taken stone as a frame of reference. Since we have taken stone as a frame of reference means non-inertial frame of reference. Therefore, this pseudo force means the centrifugal force will act away from the center. And this would be the tension in the string which will act towards the center of this circular path. Since a particle has no radial motion, neither it is moving towards center nor it is moving away from the center. Therefore, net force on the particle in the radial direction must be 0. This is what this is the tension T. So this is tension T. This is the weight mg which will act in the downward direction, and this is the centrifugal force that is mv square upon r. Okay. Component of mg in the direction of a centrifugal force, this angle is theta, so this angle would also be equal to theta. Component of mg in this direction will be equal to how much? That would be equal to mg cos theta. So this component is how much? This component is mg cos theta. Since a particle is radially at rest, okay, therefore net force acting along a radial direction must be 0. Force acting towards center must be equal to the force acting away from the center. Okay, therefore we can say that tension T would be equal to how much? Tension T would be equal to mg cos theta, means component of the weight acting away from the center plus centrifugal force mv square upon r. This is the mv square upon r which is also acting away from the center. Now whenever we move from point A to point B, suppose this is point B, so in this particular quadrant what will happen to the theta? As we move from A to B, theta increases. Theta increases. Since theta increases, cos theta, since theta increases, therefore cos theta will certainly decrease. Also, when we move from A to B, velocity reduces, means the kinetic energy gets converted into potential energy. Therefore, V reduces. This term also reduces. So we can say that whenever we move from point A to point B, both these terms, this term and this term will decrease. Therefore, tension will also decrease. But keep in mind that in this particular quadrant AB, tension never becomes zero because both terms are positive. So in this particular quadrant, particle can never leave the circle. Particle will leave the circle only when tension becomes zero. So since in this particular quadrant, tension never becomes zero, therefore particle cannot leave the circle. Okay, now we will study the variation in tension as we move from B to C. Okay, suppose at any instant of time our stone is here. Okay, and this would be the orientation of the string. This would be the radius of this circular path. And suppose at this instant of time, this angle is how much? This angle is equal to alpha. So we have taken this small angle as alpha. Now we shall have to make the FBD. Therefore, let me make it clear. The weight mg will act in the downward direction. Tension in the string will act towards the center of the circular path, and the centrifugal force will act away from the center. Okay, so these three forces, this is what, this is the weight, this is tension which is acting towards center, and this is the centrifugal force which is acting away from the center, will act on the particle. This is what this is the weight mg, this is the tension in the string, and this would be the centrifugal force mv square upon r, mv square upon r, or you can say we can consider here velocity v1. So centrifugal force would be equal to mv1 square by r. Since the particle is at rest in the radial direction, therefore net force on the particle must be zero. Therefore we can say that tension T which is acting towards center plus component of the weight, this is mg. So this component would be equal to mg cos alpha. Tension plus a component of a weight mg cos alpha will act towards the center of the circular path, and the centrifugal force which is equal to m v1 square upon r, v1 square upon r will act away from the center. So from here we can find out tension is equal to how much? This is equal to m v1 square upon r. Let me make it clear. M v1 square upon r minus mg cos alpha. This would be the tension in the string when we move from point B to point C. As we can say that whenever we move from B to C, alpha decreases. Since alpha decreases, this term cos alpha will increase. This term increases, and we know whenever we move from B to C, kinetic energy will convert into potential. Therefore, V1 reduces, and this term also reduces. So we can say that tension reduces as we move from point B to point C. Also, this term is positive and this term is negative. Therefore, they may be equal, isn't? When they become equal, tension in the string becomes zero, or when tension becomes zero, particle will leave the circle. So we can say that whenever we move from B to C, particle may escape the circle because in this quadrant tension becomes zero. Tension is very essential in order to cover the circular path. Thank you. Thank you. Have a nice day.